Hello, everybody, and welcome to this session, Deploying ArcGIS Enterprise in Microsoft Azure. My name is Nick Shampur, and I have my colleague Shailesh with me today. And today we're going to be talking about deploying ArcGIS Enterprise in the Microsoft Azure cloud. Thank you for attending. The agenda for today is we're going to talk about ArcGIS Enterprise on Azure, just looking at the overall strategy and what our vision is. And we're going to discuss some of the different options that are available for deploying ArcGIS Enterprise on Azure. For those of you who are familiar with ArcGIS Enterprise on Azure, you'll probably be interested in our What's New section, which kind of talks about what's new since the last time we met at last year's Developer Summit. So these would be the releases 10.7.1 and 10.8, and some of the new functionality and options that are available there. What might interest you is some of the deployment architecture changes we made with the latest release of ArcGIS Enterprise 10.8 on Azure. We'll dig into that in a whole lot of detail over the course of this presentation. We'll do some demos with Cloud Builder, making no assumptions about how much you are knowledgeable about Azure or Cloud Builder. It'll be all the way from a 101 to a 404 demos style. Then we'll do some demos for advanced scenarios. After all, this is a developer audience who's looking for quick ways to automate, and so we'll be doing some demos on that. And last, we'll give you some tips and tricks to keep you aware of some gotchas that you might encounter as you use our deployment tools. With that, we'll jump right in. A quick overview of ArcGIS Enterprise on Microsoft Azure. Really, this talk and everything that we're discussing today is really about us helping you being successful with deploying and managing ArcGIS Enterprise on Azure. That really is the mission statement for this team, of which Shailesh, myself, and a few others are a part of. And so how do we achieve that? First of all, we try and make the software procurement really easy. And this is by providing you with virtual machine images that are available in the Azure Marketplace. And we make them available in public Azure, the US GovCloud, which used to be known as Fairfax. We make those virtual machine images available for every release of the ArcGIS Enterprise product. And to complement those images, we provide you with deployment tools, one of which is the Cloud Builder tool, which some of you might be familiar with. And the other option is automation. And we'll get into more specifics in future slides. Now, why is this a big deal for our customers and users and our developers here? It's mostly because we don't want our users and customers to have to know or become experts in Azure infrastructure concepts. Depending on your level of knowledge and experience, you may or may not be familiar with some of these concepts. And even if you are, you might only have a superficial understanding of them. So what we want to do is sort of abstract away some of those details from you, so you don't have to worry about things like load balancers and setting up networks or firewalls and SSL certificates and dealing with all of those infrastructure concepts. So we want to make it easier for the GIS folks, developers, IT administrators, and deploying ArcGIS Enterprise in Azure in a repeatable fashion, reliably. Right? So that's really our mission. As I mentioned, one of the approaches we have is using the Cloud Builder UI tool. So the Cloud Builder is a desktop application for Windows. It provides a wizard-driven experience for customers to achieve their deployment and their post-deployment operations. So it helps you, it's a really easy way for you to get started with deploying Enterprise on Azure. And along with that, it helps integrate with sort of Azure native features. The primary one of interest is typically Azure Managed Databases, like Azure SQL Database, which is database as a service, or Azure Database for Postgres, which is the Postgres equivalent of Azure SQL Database, which is SQL Server based. And the other option is Azure SQL Managed Instance. So these are typically Azure Managed Databases that customers and our user base would like to leverage because of the manageability benefits that it provides. Other integration points include things like Azure Key Vaults for accessing certificates that are used in Cloud Builder. There's Azure Blob Storage, where you can store large volumes of imagery or tile-based data, say rasters, etc. ArcGIS Enterprise and ArcGIS servers are able to natively integrate with these storage mediums, such as object storage, and leverage them for scalability and manageability. And last but not the least is Cloud Builder integrates with Azure Active Directory, so you sign in with your existing roles and your users to access the tool. Now, switching gears to just give you a highlight of what's new for those of you who have experience with Cloud Builder and have used it in prior releases. This one probably interests you quite a bit. At 10.7.1, which is what we consider a minor release, we released automation technology related to building custom virtual machine images. One of the requirements we heard from many of our customers, especially ones with larger IT departments and a larger security department, they would really like to use custom images that they build themselves and sort of are blessed by their IT and security departments. And so basically what we did is we open sourced the set of technology and tools we use in building the same set of images that you find on the marketplace. Right? And we do so using industry standard technology, which is called Packer. Packer is open source technology released by a company called HashiCorp, and it's used for building virtual machine images, container images, etc., and is really one of the most popular tools used for capturing images. So we released those on GitHub at 10.7.1, and for customers who like to build their own images, we point them to this GitHub repository, which has a wiki that lists the instructions for building these custom images, if you will. And as you will see later in the demo, Cloud Builder allows you to create a deployment by pointing to one of these custom images that you've created, so that it sort of fits in with the rest of the story. Now switching gears to 10.8. So 10.8 was a major release with significant engineering effort that was put in. And for the first time in Cloud Builder, there's actually been a deployment architecture change. This isn't an architecture change to Cloud Builder itself, but more about how ArcGIS Enterprise is laid out and the topology that it deploys. And so what changed at 10.8.1 is we now provide a single hostname or an endpoint for your WebGIS deployments. And what I mean by that is a WebGIS deployment consists of many different interaction endpoints, or it's distributed in nature. There's different sites and base deployments. There's multiple deployments that actually make up your WebGIS. Previously, each one of those had a distinct hostname or an endpoint to access them. At 10.8, one of the requirements that our customers put in front of us is to make ease of manageability and provide a single hostname or endpoint to access all of their sites within that deployment. And in order to do so, we leverage the Azure Application Gateway, which is a layer 7 load balancer that can help us do this kind of routing and intelligent path-based routing. And once we leverage the Azure Application Gateway, we get to leverage all of its benefits, such as the potential ability to use the Web Application Firewall, or WAF, to meet security and compliance needs, and also improved monitoring, leveraging Azure tools, the ability to set up alerts, and the ability to monitor performance, requests and responses that are features of the Azure Application Gateway. We also added support for deployments that are accessible using a private IP. This is a scenario that customers who have private connectivity between their enterprise network on premises to the Azure cloud can leverage. In such a deployment scenario, there isn't a public IP for the ArcGIS deployment, and any public IP requirements are just for the Azure Application Gateway control plane communicating back to Azure. The last change at 10.8 is now we have separated out the tile cache data store onto a separate tier of machines. As some of you might be familiar, at 10.8 you can actually cluster your tile cache data store, and for its storage of scenes and scene layers, we now support within our Cloud Builder tool the ability to put those on a separate set of machines such that you can scale those out and in as needed. Let me dig in a little more on concepts with respect to site deployments. Many of you are familiar with the sort of the components or architecture of ArcGIS Enterprise. At the center of it is the portal for ArcGIS, also known as the hosting server or base deployment. to which you will add additional server sites, like an image server site, or geo-event, or geo-analytics, or a general purpose site. And these sites are typically federated with the base deployment. And then on the bottom tier, you have several data stores, such as the built-in relational data store, or the tilecache data store that I just mentioned. If your scenario involved big data or real-time analytics, you would typically also deploy the spatiotemporal big data store, or have additional big data file shares that you can access. So as you can see, there's many components and deployments, also known as sites, that comprise your ArcGIS Enterprise deployment as a whole. So in addition to all these different components, you have the ability to deploy each one of these sites either as a single machine or as multiple machines, depending on your workload requirements. And for some of the larger deployments which would like to separate out workloads, you have the ability to separate out different components of the ArcGIS Enterprise-based deployment into multiple tiers. So this is a scenario where you have the portal running on one machine, and you have the hosting server on another, and then you have the data store on a separate tier. So this allows you to separate out workloads into separate tiers. In addition, you can choose to use various storage options with the deployment, such as for the server's configuration store or content store. You can put them in the file share on a VM, or you could use Azure blobs and tables to store the configuration and content store. Or you could use Azure files. We'll see these options in a later demo, and also we'll talk about some pros and cons of each one of those. Now coming back to the change at 10.8 with the deployment architecture and deployment patterns. Right? Before we jump into that, let's just take a quick high-level look at the system architecture, if you will. In version 1, this was sort of the conceptual software architecture, where you had at the center of it all was the base deployment, with the web adapter, the portal, the hosting server, and the data stores. And this box comprised one deployment of your base. And then you had additional deployments or sites for each of the server-based roles. It could be a notebook server, a general purpose ArcGIS server, an image server, geo-event, geo-analytics, or geo-enrichment. What's key to understand in this diagram is each of these sites was behind a load balancer, which was associated with a public IP that had its own fully qualified domain name. In other words, each one of these sites was accessed using its own fully qualified domain name or host name. In V2, we've sort of switched that around. And now basically you get a single host or a single endpoint through which you can access all of the sites within your WebGIS deployment. And the way we differentiate between those sites is using the application context. So in this case, your hostname / portal will take you to your portal. Using the server context of server takes you to the hosting server. Notebooks takes you to the notebook server. Image takes you to the image server, and so on. So you get the idea. So basically now you have one endpoint, which could be something like mygis.contoso.com, and you're actually able to access all of your sites from that one endpoint. This makes it nice and easily manageable in terms of SSL certificates, a single endpoint to monitor, a single endpoint to scale, and visualize all of the requests and responses that are going on within your site. Illustrating this difference in a different architecture. For the single tier deployment in V1, it basically had one or two machines which were behind a load balancer associated with a public IP. So this was the version 1 architecture. In version 2, basically the load balancer, the layer 4 load balancer, also known as the Azure load balancer, is switched out for an application load balancer, which is now smart to do the path-based routing. Now let's look at multi-tier based deployment and what changed between V1 and V2. So in V1, the same way, you could actually separate out all of the workloads, portal, the hosting server, and data stores into 4 separate tiers. And access to the deployment was through a reverse proxy or web proxy set of machines. And there was a load balancer in front of those 2 machines, which did the path-based routing to the portal or server based on application context. Each of the portal and the hosting server were behind an internal load balancers that routed traffic to the different machines that made up your portal or server. Again, this was your base deployment, and it had a load balancer and a public IP associated with it. What's changed at V2 is we no longer have the reverse proxy tier of machines. The application load balancer is essentially a reverse proxy that does the same function that we used to do previously with the reverse proxy running IIS. So in this architecture, the application load balancer sends traffic directly to the portal or hosting server, depending on the application context as before. Now we looked at base deployment. Let's look at some scenarios for some of the server-based roles. Like this was a scenario where I'm trying to deploy imagery in the cloud. What would my deployment patterns be? In V1, you deploy your base deployment, which is shown by this box on the top, and then you would have additional deployments for your image hosting server and your raster analysis server. Each of those, again, would get deployed in typically a separate resource group. It would have its own IP and its own public IP, its own host name and DNS associated with it, and those two would be federated. And you typically use something like cloud storage to store your raster data. In V2, now there's basically a single view or a single endpoint through which you access both your base deployment, that's using portal and server as context on your left, or using image or raster analysis or whatever context you provide for your raster analysis server. So that's how you would now deploy something with image hosting and raster analysis if you're in the V2 architecture. Now let's take another example. If this happened to be a real-time GIS deployment with GeoEvent and GeoAnalytics. In the V1 architecture, it sort of looked like this, where you'd have your base deployment. In this case, it happened to be a multi-tier base deployment with server, portal, hosting servers, and the spatiotemporal data store. Then you would deploy a GeoEvent site, which had its own public IP and a load balancer. And you do the same for the GeoAnalytics. And GeoAnalytics is running your distributed compute with the GeoAnalytic functions. And these would be federated to your base deployment using its own set of host names. And so the federation host names would be different from the host names that you used for your base deployment. In V2, this has been simplified or cleaned up, where basically there's a single endpoint, a single public IP, a single SSL certificate that you need to manage, and through which you can access your base deployment through portal and server. You can access your GeoAnalytics through GeoAnalytics, and you can access GeoEvent and its manager and admin interface in similar fashion. And the spatiotemporal data store is obviously needed for this scenario. So hopefully that gives you a quick idea of how things have changed between V1 and V2. With this, I'll switch over to Shailesh, who'll do a demo of Cloud Builder. While he gets started, while he gets his machine set up, some quick 3 steps for getting started. Obviously, you get an Azure subscription, and then you get your ArcGIS Enterprise software licenses. I do want to call out that our marketplace offers are bring your own license. So you continue to procure your license through the regular means, working with your account manager and accessing license files through my Esri. None of that has changed. Those are prerequisites to using our deployment tools in the cloud. And last but not the least, you download the ArcGIS Enterprise Cloud Builder. Here's a quick short URL for you to access the Cloud Builder install. It's a really quick install. I think it's under 15 to 20 megs and typically installs in less than a minute. So with that, I'll switch over to Shailesh.
Hello everyone, good morning. I'll start my demo by launching the installed version of ArcGIS Enterprise Cloud Builder 10.8 for Microsoft Azure. I will sign into my Microsoft Azure and will be presented with a list of all the subscriptions that I have access to. On selecting one of these subscriptions, I will be taken to a page of catalog of all my ArcGIS Enterprise version 2 sites. On this page, I can either choose to deploy a new site or manage my existing deployments and its associated federated sites. At 10.8, we merged the view of all the ArcGIS Enterprise based deployment, which includes your with its federated sites. You can either choose to do manage in machines and site, add server machines, add data store machines, RDP to an existing site, or delete a site. On this page, you also get the option to view all your ArcGIS Enterprise version 1 sites and all your ArcGIS desktop deployments. Coming back to ArcGIS version 2 sites, I'll start with the deploy a new site workflow. On the first page, you will be asked to choose whether you want to deploy an ArcGIS Enterprise-based deployment or do one of the server-based roles. Those are the GeoVent server, the GeoAnalytics server, the image server, the notebook server, or the general purpose GIS server. While working with the WebGIS pattern, you would essentially want to start with the ArcGIS Enterprise-based deployment, that is, the portal for ArcGIS, ArcGIS server, and the ArcGIS data store. I do so by selecting the first option and clicking Next. On the image option page, you will be first asked to specify a resource group. In this, you can either create a new resource group by specifying the name and the region on which you want to create that resource group, or you can reference an existing resource group. One pattern that you will find consistent across Cloud Builder is that you can either create new Azure resources or reference existing ones that have been created using the Azure portal. In the next set of options, you will be asked to specify an image that you would like to work with. You can either choose an ArcGIS Enterprise 10.8 Marketplace image and the region you want to deploy it to, or you can choose an image that is already within your subscription that you might have built using the ArcGIS Packer templates provided by Esri on GitHub. For this purposes of this demo, I choose the ArcGIS Enterprise 10.8 Marketplace image. In the next set of options, you will be asked to specify whether you want to do a single tier deployment or a multi-tier deployment. If you do a single tier deployment, as Nikhil suggested, all your ArcGIS components will be on a single box. That is the ArcGIS server, ArcGIS data store, and the portal for ArcGIS. As part of this deployment, you can choose to add a secondary machine. You might want to do this if you have requirements around capacity and resiliency. As for the multi-tier deployment, we will come back to that in a little bit. On clicking Next, I will be asked to specify some of the networking options that are to be used with the deployment. The first set of options are around the virtual network. The virtual network, you can either reference or choose to create a new one. As part of this deployment, you will also be asked to choose two additional subnets. One that is for your virtual machines, the other one for your application gateway. The application gateway subnet needs to be a different one from your virtual machine subnet, and it also needs to be an empty one. The next set of options is about your Azure Application Gateway's front-end listener. Front-end listener is basically an ingress point that will intercept your incoming requests and route them accordingly to the associated backend pool, that is the server or the portal, or one of the federated servers. You can either choose a public IP as your ingress point or a private IP. You can either reference a public IP or you can create a new one. The public IP that you create needs to be a unique one within the region that you selected. In my case, it's the East US Azure region. When you choose a new select a private IP, it needs to be the one from the application gateway subnet. This is new at 10.8 and might be required by some folks who have requirements around not allowing traffic from the public internet and from within their subnet or from within their virtual network. Moving on, I will be asked to specify a SSL certificate that I want to associate it with my application gateway's front-end listener. The SSL certificate can either be a self-signed certificate that is generated automatically by the Cloud Builder at deployment time, or it can be a certificate issued by a certificate authority. If I choose the second option, you need to specify a domain name or the CNAME, the file path to the certificate file of the .pfx format, and the password associated with the file. For the purposes of this demo, I'll use a self-signed certificate. On the next screen, I will be asked to specify some of the machine options. I start with the machine administrator credential. The first one is required by Azure to provision the virtual machine in your Azure subscription. Next, you can also specify the virtual machine OS disk type, the machine type, the size of the OS disk, whether you want to add a data disk, the type of the data disk, and the size of that data disk. Additional options available to you are the time zone you want at the machine startup time, whether you want to join to an Active Directory domain. You can do so by clicking this checkbox here, filling the Active Directory domain name and the username and the password of the domain administrator. The next set of options is the name of the machine, whether you want to enable the automatic operating system updates and enable a remote desktop access on port 3389 by deploying a separate jump box as part of the deployment. Once you do this, you will be taken to the next set of options that are around the ArcGIS data store that you want to enable with your base deployment. By default, relational data store is enabled. You can either choose to enable tile cache and the spatiotemporal data store as well. As part of the deployment, you will be asked to provide your license and this licenses and credentials. In this, the portal license I've already downloaded to my local machine and will browse out to now. You also need to choose the license user type available in your license file. For this purposes of this demo, I will use the creator license type. Next, I choose the server license type. Server license file. Next is my primary site administrator for that will be used to create my portal site and my server site. Next is this ArcGIS service account. That is a Windows service account to run my ArcGIS services. Clicking next, I will be taken to some of the deployment options that I need to specify. The first one is the storage account that I want to use for the Cloud Builder to function. In this storage account, the deployment artifacts generated by the Cloud Builder based on your inputs are stored. Cloud Builder will use these storage account to will use this storage account to trigger ARM template deployments in your Azure account. You can also choose to enable Azure monitoring by clicking this checkbox over here. You will need to associate Azure Monitor Log workspace. You can either choose to create a new workspace or reference an existing one. As part of the enabling your Azure monitoring workspace, you can also choose to harvest Azure's ArcGIS server logs to Azure Monitor. Finally, on this page, you will be asked to specify whether you want to choose an Azure file share VM or one of the Azure storage options for your ArcGIS server configuration store and the portal for ArcGIS content store. If you choose the latter option where you choose an Azure storage option, you can choose an Azure Files or Azure Blob Tables. If you choose the latter, you need to specify an Azure storage account which you can create or reference. Finally, you will be presented with a summary page which you can review and save out to a text file. Next, you can also save the automation artifacts and generate a cost estimate. As part of this save automation artifacts, you can generate Visual Studio Deployment project, PowerShell scripts, and cross-platform scripts. Now, once you hit finish, you should have a working base deployment within an hour or so. Now, coming back to the second screen of this workflow, you can choose to do a multi-tier deployment as well by unchecking the single tier deployment checkbox. Most of the options remain the same during this workflow. Only options that you will see appear are on the machine option page, where you can choose to use the default name and sizes for the machine or specify names and sizes for individual machines. If I choose specify names and sizes for the individual machines, I will see a new screen pop up after the ArcGIS data store options page. In this page, I can choose to specify new names for my machines or increase the number of machines in each tier. I can additionally choose to specify the OS test type, machine type, size of the OS test type, whether you want to add a data disk as before, as I did in the single tier machine size. Next, on the summary page, I will see now it's not a single tier deployment, but instead a multi-tier deployment where all my components are separated into different tiers. Now that I have a base deployment, I can also go back and do a server-based role deployment. I choose the general purpose GIS server for the purposes of this demo. Most of the options will remain the same, except that you will be asked to choose whether you want to do a standalone deployment or federate the new deployment, server-based deployment with an existing deployment. I choose the second option and fill out my parameters, where I will be asked to choose the deployment endpoint and the portal site administrator. Next, I also get an additional option to deploy a database. As Nikhil suggested, you can use the Microsoft Azure SQL database service, Microsoft Azure SQL Managed Instance Database, Microsoft Azure Database for Postgres, or Microsoft SQL Server on a VM. For the purposes of this demo, I'll use none as my option and move forward. Most of my options remain the same. I don't have to specify my portal license anymore. Additional option that I get with this workflow is to choose the server-side context, which is essentially choosing the web adapter name for your deployment. Since we have a single FQDN for my whole base enterprise deployment stack. In the summary page, you will now see my GIS server role is set to yes. And once I click finish, I should have a working deployment within 30 to 45 minutes. Now, coming back to my deployment screen, one thing I failed to mention was what about my V1 sites? I can still go and upgrade my V1 sites and it's still supported. Once I upgrade my V1 sites, I will still have all the deployment operations, post-deployment operations that I had in 10.7.1. That's it for the demo for now. I'll switch back to Nikhil for automation concepts.
Thanks, Shailesh. That was a great overview of Cloud Builder and the UI. I think really, I hope we were able to make it come across that the Cloud Builder provides a lot of flexibility, a lot of options, and also provides a really easy way for people to get started and deploy ArcGIS Enterprise in a single machine, single tier, all the way through multi-tier with multi-machines, and really set up your distributed WebGIS with just a few click of buttons and some information. Now switching gears a little bit and taking it up a notch. So Cloud Builder is perfect and it's a UI-based tool, but what I'd really like to highlight is Cloud Builder is basically a pretty UI on top of automation. Right? Today we live in the world where automation is a key to success for digital transformation in IT. And so we need to basically support our customers and our users who also would like to automate the same way that we have automated deployments of ArcGIS Enterprise and put a UI in front of it. So if you recollect, at the end of the Cloud Builder screen, on the summary page, there was the option to generate automation artifacts. Now, these are the same automation artifacts that Cloud Builder itself would use in transient fashion when it's deploying. But in this case, you can actually save those out and then integrate those into your own workflows for automation. As Shailesh mentioned, we have the ability to generate a Visual Studio deployment project. So for developers who are familiar with that, you can pull those artifacts in and extend it or customize it. And then that's one entry point. We also support PowerShell scripts that act as the bootstrapping of triggering your ARM deployments. Or you could use cross-platform CLI or Bash scripts to be the entry point to which you start. The key thing to bring across is we achieve all of this through automation using Azure templates. So Azure templates are a way that you're able to spin up these deployments and different site topologies in an automated fashion and repeatable fashion, if you will. So we build on top of existing Azure automation technologies. So in summary, Cloud Builder provides you a wizard-driven deployment experience. Another way to look at it is it's also a designer to generate these automation artifacts. So as you step through the UI and decide on your site topology, single machine, multi-machine, these types of databases, these kinds of data stores, you're in a sense designing your deployment and setting it up to be able to automate it, to be deployed using automation. So if you look at some of the artifacts that we generate, as I mentioned, it generates the ARM template. And then what's really nice is it also generates the template parameters. And so this is all the information that you filled out in the different screens on Cloud Builder. So it saves all that out. It saves out some of the automation scripts, the scripts that power your deployment, like the PowerShell DSC that executes on the machine, or the Bootstrap scripts that execute on the automation machine. It saves all of that out. In addition, it'll put the licenses and the certificates that are needed in a location that the scripts expect them and the automation expect them. So that really encapsulates all of the deployment artifacts that Cloud Builder uses under the hood. Now, when would I use one versus the other, right? Would I use Cloud Builder versus automation? And really, it comes down to where your scenario lies in terms of power versus simplicity. Obviously, Cloud Builder with the UI is the simplest option and the fastest to get started. But as you need to have more advanced scenarios or a scenario that Cloud Builder doesn't natively support, you might find yourself having to extend it using one of the automation options. So Cloud Builder, wizard-driven, versus if you need to customize or extend it, you're looking at one of the automation options. So either using Visual Studio or PowerShell or Bash to trigger your deployments. Now, should you choose to go down the path of automation, this really opens up a whole world of extensibility and customizations that you can make. Here are some of the ones that we have heard from customers and business partners on customizations they typically make. One is Cloud Builder, because it's UI-driven, has limited real estate. We don't provide you the option to name all your resources, right? Things like load balancers or disks or network interfaces. They have fixed naming convention. If you have organization requirements to change that, you will have to get down into the automation and kind of roll up your sleeves and deal with ARM templates. Another restriction in Cloud Builder is that we only put our virtual machines in one subnet and your Azure Application Gateway in the Azure Application Gateway subnet. If you did want to separate out your machines into separate subnets and create a sort of a DMZ style environment and set up additional network security group rules or firewalls, you will typically have to customize our ARM templates to do that. Another thing we do is we don't explicitly set up network security groups in your VNets. If you need to do that as part of deployments, that's another scenario that you'll want to extend the system with. Today, we integrate with Azure Monitor in terms of setting up the deployments, but we don't set up any alerts. So this is another scenario that you would customize with the ARM templates. Additional options are things like configuring VM backups or setting up scheduled maintenance or setting up auto shutdown. All of these are options that you'll need to customize the ARM templates if you'd like to achieve. Remember, this is an advanced scenario. If you roll up your sleeves and get into this, it is assuming that the training wheels are off and any edits that you do outside of Cloud Builder are sort of invalid, right? So once you go down the path of automation, you are down that path of automation, and there's no back and forth between Cloud Builder, if you will, depending on context, if you will. Now, once you're in this world of automation, now it opens up a whole world of integration possibilities. Now, there's various CI/CD pipelines and configuration systems. Many of you are familiar with some of these tools like Chef and Puppet and Vagrant. We can integrate with them all, right? And the reason is it's essentially at this point a command line invocation that you can basically integrate this deployment piece into your pipelines. And we're going to show you one example of this. And Shailesh is going to walk you through a demo which shows you how to deploy using automation and the Azure Cloud Shell. With that, I'll turn it back to Shailesh.
Coming back to the demo for ArcGIS Azure templates that we introduced at 10.7, which is used to power Azure Cloud Builder, ArcGIS Cloud Builder 10.8. I would like to use the Azure Cloud Shell experience with the Bash experience to do my demo. As part of this demo, I will first create. Sorry, it's taking a little bit of time to start.
Could be the internet acting up.
No,
there we go.
There we go. So, as part of this demo, I will create a directory where I will store all my artifacts and clone the
Do you want to delete the
Yeah.
player run?
Sorry about that. As part of this demo, I will be creating a directory where I will clone my Azure templates repository and store all my artifacts. As part of this deployment, I will require three essential things. The first is the server and the portal license, the certificate file that I would like to be associated with my application gateway front end, and the domain name for the public IP. As part of this demo, I will first start by uploading these artifacts. The portal license file. Next is the server license file. And the next one is the certificate that I want to associate with my application gateway front end. Once I have that, I will git clone my ArcGIS Azure templates repository.
CD. Yep. So we have a nice working directory to work off of.
Now that I have that repository cloned in, I will cd into the release folder that we provide for 10.8. As you can see, I have all the automation artifacts that Nikhil showcased a little while ago in here. I also see a bunch of sample parameter files in the sample parameter folder. And the associated template files with those sample parameters. These are some of the basic deployment patterns that we support in Azure Cloud Builder as well. You can view these parameter files in a nice GUI editor view using the VS Code experience provided by Azure Cloud Shell, which is embedded with it. As you can see, this is the template file.
Really convenient to have a full screen editor, full text editor inside of Cloud Shell. Very nice.
Next, as part of this, I will edit my base deployment single tier parameters file, which I will use to do my deployment with. I already have this parameters filled out in a separate file, and we'll just copy it over.
So in a nutshell, we provide you with sample parameter files that are also on the GitHub repo. So they have some placeholder text for you to fill out. So in this example, Shailesh, in the interest of time, is just going to update previously filled out information.
Now that I have filled out and saved this information, I will copy my artifacts that I uploaded to this working directory.
License and certificates.
Now I will set the permissions on the deployment script as I downloaded these from the internet. Once I have that, I'll be able to use the deployment.sh script to do start my deployment. I need to specify the template file, the parameters file, the resource group which I want to deploy in, the region associated with that resource group, the storage account where I will store these automation artifacts into, and the container name. Once I have that, the shell script will do what exactly the Cloud Builder does. It will go and store these automation artifacts in the storage account and trigger a ARM deployment in Azure Cloud. As you can see, it's uploading the artifacts to the storage account as of now. In a few seconds, you will be able to see the deployment show up here.
So essentially what you're seeing now is essentially the same that happens when you click that finish button within Cloud Builder. You would see a similar ARM deployment being triggered and running as of now.
See, cool. If we refresh now, we can see the Azure deployment has started. It will take similar amount of time, that is 1 hour, to complete this deployment, and you should have a fully functioning base deployment ready for you to go. Switching back to Nikhil.
Thanks, Shailesh. Yeah, that was a really powerful demo showcasing automation. I'm sure by now a lot of you are envisioning lots of scenarios you'll be able to integrate our automation artifacts into. We have a lot of our business partners, system integrators who leverage our automation artifacts to essentially deploy repeatable, maintainable deployments of ArcGIS Enterprise in their Azure environments. With that, I'll just switch tracks to tips and tricks and troubleshooting. Just some common gotchas we have heard from users of Cloud Builder and our artifacts. One thing to keep a lookout for is Azure itself. Not all regions have all VM sizes. There are a plethora of VM sizes available, but not all of them are available in each region. And some of them you need to be sort of whitelisted into to be able to have access to that. So work with your IT department and your Azure subscription to get those all figured out. The next one, the common gotcha, is Azure quotas. This is an evolving space where Azure has started to enforce more constraints on virtual machine sizes and quotas within individual Azure regions. So make sure you have enough capacity in terms of CPU cores and databases and storage accounts to be able to successfully provision. Some best practices is try and use separate resource groups for each deployment. So that way you have sort of control over access and auditing. It's usually a best practice. One prerequisite step that we didn't showcase today is enabling programmatic deployments of the ArcGIS image offer in the marketplace. This is part of our documentation as well. One question that always comes up is help me choose between the different storage options for the configuration and the content store. And the choice today is between a file share virtual machine, Azure Blobs and Tables, and Azure Files. Now there's pros and cons to each one of them. At this point, the advice from the product team and based on our testing really is to stick to a file share VM because it gives you the best of all worlds in terms of performance, latency, predictability. Azure Blob and Tables is good and provides scalability, but you today cannot put things like the server directory on it. Azure Files is a sort of a beast that has given us mixed results. And even with the premium tier of Azure Files, you typically are looking at a really large Azure Files queue with large amount of IOPS to get decent performance. Azure Files is an emulation of SMB, and so we typically see problems with lots of small file uploads, think portal content, and also things like file locking operations that ArcGIS Enterprise leverages that can sometimes be problematic. So at this point, our recommendation really is to stick to a file share VM. And remember, a single machine virtual machine in Azure has a 3.9 SLA. And if you couple that with scheduled maintenance, you will be able to sort of achieve much higher levels of SLA as well, which is the typical knock against the file share VM, that it's not highly available. But I think for most customers, being able to focus on a disaster recovery scenario will help them get around the file share VM restriction. And last but not the least, if you have deployment failures, as we mentioned, everything we do is Azure native. So there's an ARM deployment that gets triggered every time you click finish or use automation. Examine that in the Azure portal. Try and see why it failed, right? See if there's some clues that Azure might provide. And if that doesn't work, then look for log files that Cloud Builder creates locally or on the machines. Make sure you're giving strong passwords for your Windows credentials. This is for the administrator account and for the ArcGIS service account. Windows is again an evolving space with credentials and password management, password history. So try and provide strong passwords to avoid failed deployments. And then I always typically recommend starting with small deployments, getting your feet wet, and then going bigger as needed. And if all else fails, submit a support incident, and you will typically be required to provide the log files and the deployment summary page. With that, I'd like to conclude this presentation. I have both the presenters' names and our emails on there. If you have a question that you would like answered, do shoot us an email, and we'll do our best to try and get back to you. Thank you.